Which brings me to this. Is that all I need to know to tell time and position? No, because I haven't actually gotten to the astronomical part of it where or the terms that we actually need to use and start to use. So this is where it starts to get a little bit technical, and you need to sort of tap into your creative side and visualize the Earth. So in astronomy, we've got the Earth, and then we've got something called the celestial sphere. So we assume that every single star in the sky is sort of plastered or sort of stuck on like an outer circle. And we know that's not the case because we know some stars are really close to us, some stars are really far away from us. So they're not the same distance. But in terms of needing to tell position, time, and fix sort of what's going on, we sort of have to assume that we stand here and then all the other stars are just on this 2D sphere on the outside. So that's our celestial sphere, and then we've got the Earth. And just like how we have latitude and longitude here on Earth, we have something called a celestial projection. Celestial is just a fancy word for saying things in space. So you've got stuff here on Earth, and we have coordinate systems that work that we all agree to. Same thing, we've got a coordinate system in space, which is just projected out from what we use here on Earth. So, quick geo lesson. This is your latitude and longitudes. Your meridians go all the way through. This is your prime meridian, which is like your 0 coordinate. And at this point where your prime meridian and your equator intersect, so they line up, that's sort of like your 0, 0 point. And then we just work from there everywhere else through. So we divide the whole Earth up into segments, and then we're able to work our way through, but we need to know where your 0, 0 point is, latitude and longitude. So that's over here. Lines up with the Greenwich Observatory up over there on top. So we're happy with this. So remember, this is the Earth, and if we were to project it, that blue thing is the Earth. Clearly this is a northern hemisphere diagram, not a southern hemisphere one. But this outer circle that you can see, that's where all the stars sort of are stuck. And then we use that as our plane. That circle that you can see there, that's the celestial equator. So that's our equator pushed out onto the celestial sphere. So where that would be. Okay? So just where our equator would be, pushed out onto the celestial sphere. And then if we draw sort of our rotation axis, that's just letting you know that this is the way that this Earth is spinning along this point here, going through our north celestial pole and our south celestial pole. Right? Now remember how I said we're not really spinning in this way. We're actually tilted off onto the side by about 23.5 degrees. So technically this is how it looks. You need to know a little bit more. So you've got the celestial sphere, you've got the celestial equator. There's another line in the sky that is actually very important that's called the ecliptic plane. So the ecliptic plane, if we were to look outside in the sky, is the path that the sun would take along the course of the year. So the sun follows a path in the sky. It is also the path that the moon follows, and also the path that all the planets follow. So if someone tells you that all the planets are aligned, they're always aligned. They're not going to be scattered across the sky. They're always sitting along this ecliptic plane. It is the plane of our solar system. Alright? So we've got our celestial equator, and we've got this ecliptic plane. Now remember how I said we have that 0, 0 point on Earth? We've also got that 0, 0 point in space on the celestial sphere. If you don't know where that is, it is actually at the intersection of our ecliptic plane and the celestial sphere. And that's got a very cool name. It's called the first point of Aries. And it's got the symbol of the ram. Because when we did set up the system, that point, if we projected it out into space, was actually in Aries. And we'll come to it. Right now, it's not in Aries anymore. So it's called the first point of Aries and has nothing to do with Aries. But we'll get to that. So really important idea of celestial equator, ecliptic plane, that intersection point, and your first point of Aries. All right, so keep that in the back of your head. Here's another image. There's something else you also need to know in order to tell time and position in astronomy. It's called right ascension and declination. And I always get this wrong, but I studied for this one. So,
Nice.
Declination is sort of your up and down movement. So this is the equator, or the celestial equator. Declination is just your movement up from the equator or down from the equator. And it's divided into degrees. So if you go up, you'll get positive values. If you go below the equator, you get negative values. Right ascension, on the other hand, has to do with hours, minutes, and seconds. So the way that these are divided, declination is measured in degrees, minutes, seconds, and smaller parts of it. And then right ascension is divided into hours, minutes, and seconds. So if we were to divide the entire circle out into 360 degrees, then every sort of 15 degrees counts as 1 hour as we go through. So we divide it up into 24 hours as well. Are you with me? Mm-hmm. Cool. Now, the thing is, you don't just take the right ascension from any point. Oh, give me 1 second. You have to measure it from that first point of Aries. So this vernal equinox is another name, is that point where your celestial equator and your ecliptic intersect. And from that point eastward, you measure the right ascension. Cool? And then you measure it out, and then you've got declination, positive or negative. Alright, so these are the coordinate systems that we use to be able to tell position. So if you tell an astronomer that there is a certain object at this right ascension and this declination, if they know what they're doing, they should be able to pick it up on their telescopes. And if the telescope is a go-to telescope and has GPS systems programmed into it, they can type it in and bring up that object for you. Alright? So these astronomical coordinate systems are really important if you understand what they mean. Here are some other terms you also need to know. Zenith, which is straight above your head, and nadir, which is straight below you. So every person has their own zenith point, because that's going to be whatever is directly above your head. So if you ask someone to look at zenith, technically what they should do is just look straight up, and that is what they will see at that point. So these are just terms for me to let you know what they are, because we use them, but practically nothing today. Alright, so these are just terms you need to know. And then another thing to keep in mind is that if you were to look at, I just found a random image on Google. I have no idea what this is for, but if we were to look at an object, it would just be like, this is the star. The alpha is just right ascension, and then I don't know what the Greek equivalent of it, but that is your declination. So this is your right ascension coordinates, declination coordinates, and then a whole bunch of information about it. And at the top, you see something called J2000. That tells you about the epoch. So there's something really weird in astronomy. You can't keep things going or ticking along a certain way for too long, because things are always moving, things are always changing. In fact, I think our astronomical systems will switch at 2050 to the next epoch. So every 50 years they have to update their software systems in order to keep up with what the Earth is doing. And I'll tell you exactly why. It has something to do with spinning tops. So the Earth does a lot of fascinating things. It's spinning, it's going around the sun, but it's also rotating on its axis just like you would have a spinning top, which means whatever you see now actually changes over a period of time. So the Earth does one wobble every 26,000 years, which doesn't make too much of a difference now, but astronomers can actually see this variation year to year, and in 100 years or in 1,000 years, it does make a difference, and we can see that from astronomical texts that people have in their recordings that, say for example, the North Star, what they had back in the day, is not the same North Star that we have now. So back then they had a North Star, it was called Ubin. I think it was in the constellation of Libra? Maybe, I have to check that one. And now, for us, the North Star, or the Northern Hemisphere, is Polaris, right? And in another 11,000 years, it's going to be something totally different. So I'll show you a video of how that works, but keep in mind that point, the first point of Aries, that's going to be important to look at, and also the North Celestial Pole and the South Celestial Pole, and that's going to give you a little bit more of an idea of this wobble that's happening. So, one cycle takes 26,000 years, and you can see that symbol of the ram going through. So in 1000 BC, it was Aries. Now it's currently in Pisces. So that's why I said the first point of Aries is not actually in Aries. The reason why it is changing all the time is because the Earth wobbles. The word we use for that is precession. And as you can tell, that first point of Aries is actually just making its way through the different constellations along this band. That's not a weird band, that's the ecliptic plane, or the band of where all the zodiac constellations sit. So if you see that sort of changing of those names, you'll also notice they're actually the zodiac constellations. And then you'll see on top a nice wobble, or a nice yellow circle being made. That is where your North Celestial Pole is changing or altering over a period of time. If we were to project this out into the sky, we'll actually be able to see how the North Star has actually changed over a period of time, and how it will change in the next couple of years or so, next couple of thousands of years. So that's where it was, coming through. And remember, our North Star is sitting right over here at the moment at Polaris. And this is all to do with precession, and then how it's going to keep going around, which means everything that we have in the sky is going to slightly alter and change, and we need to keep track of these sort of movements, subtle movements, if you're doing things over 50 years and 100 years. Clearly, if I'm doing it tonight and tomorrow night, it's not going to make that much of a difference. But it is a good thing to have this in the back of your head, because actually, it's quite cool. Next thing I want to show you is, this is what our sky would look like if we went outside in maybe an hour or so. That cross that you can see with SCP, that is our South Celestial Pole. Quick navigational tip, where the South Celestial Pole is located in the sky, if you can sort of measure that angle from the horizon, it tells you your latitude here on Earth. So if you are sitting at the horizon, then you know, if the South Celestial Pole sits at the horizon, you know you're at 0 degrees, because it is, you're at the equator. And then if that South Celestial Pole sits right above you, you're at 90 degrees, right? So directly 90 degrees away from the equator. That blue circle that we have there, it's not random, that is called the circumpolar region, which means over the course of an entire night, those stars won't appear to set. They'll just make a massive circle in the sky, and it's really cool because we've got a huge circumpolar region here in New Zealand. Coming back to this particular animation, you can see the stars that won't ever set. It kind of just brushes past the horizon, and you can always just see that there. Obviously, as you move further down towards the equator, your South Celestial Pole position is going to move, and your circumpolar region is going to get smaller. So, actually used stellarium to go and find out what it would be like in Australia. It's not too different. This was, I think, in Sydney. But if I went down to maybe Indonesia, then my south celestial pole is up here, which is, I think, about 7 degrees or 9 degrees at this point. You can still see the Southern Cross. And so even if you go further up north, you'll get to a point where you will still be able to see the Southern Cross and our southern constellations. But obviously, the further north you go, the less likely you are to see them. For us here, the Southern Cross, circumpolar object, which means we can see it all the time throughout the year, which is great. So I've kind of bombarded you with a lot of information, and hopefully we're going to be able to use this to be able to tell time, and maybe Andrew can give me a bit of a hand, but we'll be able to use our hands and be able to use a few other tools to actually be able to use this to do some celestial navigation. But it's important that you have an understanding of what these words are when people use it, what they mean, because astronomers, they throw it around all the time, and you kind of have to sort of keep up. So a little bit of an idea of the night sky. What I want you to do is my thing for you, my call to you, is for you to go outside. It's clear tonight, which is great, before this presentation started. It's for you to actually take a snapshot of what the sky looks like at, I don't know, 9 o'clock or 9:30, and then keep a track of it for like 2 weeks or 3 weeks and see how that sky changes at that certain point of time. Once you see that gradual change, you get a whole new appreciation for how the sky is actually moving and changing. Remember, sky isn't actually moving. What we see is just a reflection of the Earth's motion. Everything else just appears to be fixed. Cool? Let's see how much you kept and retained that. We're going to do a quiz. So if you do have your phones, I'm going to get you to take them out. You don't have to do this. It's not compulsory. There's no prize. But it's this is the password to Saturn if you need it. And it's really important you get the right number of Z's in the right order. So it's quiz, 1Z, is izz.com. For those of you that have come to one of my online quizzing things, this is a different platform that I'm using. I use it with my kids at school. Have a go. While you guys are doing this, I'm going to... Oh, okay. Looks like it's gone. Give me 1 sec. So here is the... No. For those of you that's still looking at it, make sure you do put the URL correctly, otherwise it asks you to log it in. And for those of you that are in, I'll just give you another 30 seconds to get in. Yeah, you should. I'm just going to host a game, and then it'll ask you for a code. That's the code. But I'm just going to come back to this just in case no one's logged in and people are still getting their Wi-Fi sorted. The link. There's only like 13 questions. The great thing is you can put your name in and then we can see how people are doing. And then we won't do a name and shame, but we can. So if you just do, you've got to put in that one. So you've got to say join.quizzes.com, because if you put just quizzes, it takes you to another site. So if you put join.quizzes.com, it'll take you straight to the game site, and I'll give you the code. The code is 296600. You just got to make sure you do join.quizzes. It's QUIZ Q.izz. Yeah. Q. Let's see if we can get that back up.
Yeah.
Whoa. So you have to put the URL right. You've got to say join.quizzes.com. And if you put it right, it should come up with like a little purple screen with things going around.
Yeah.
So you should see a little thing that says enter code. And then the code is, there you go. That's your code. So we've got a whole bunch of people already in there. Someone actually put the code as their name. So remember the URL is up there. The code is up there. I'll start the game. You're not answering the same questions at the same time. You can join in at any time as well. Alright? Alright, let's go and see how you guys do.
2, 1.
And so we can just see how everyone does in terms of their questions and the results sort of just pop up straight away. So have a go, take your own time, pace yourself, and see if you can remember any of the stuff that we did. So 85% accuracy as a group. I'm going to take that positively. That's great. Dropping, fine. You should be able to see how you're going on a little chart afterwards. Remember, if you haven't joined, the URL is still up there, code is still up there, you can join it at any time. The Dennis seems to be doing quite well, leading the board, along with Trip Andrews.
I got 2 questions.
We've got some people that haven't got many mistakes. Every time you get something wrong, it shows up with the red bar. Everything you get right comes up with the green. We've got about 32 people playing. We're going to have fun. A few people just keep on going. So we're sitting at 81% as a teacher. I'm pretty happy with that. We're going good. And we're getting people that are finishing up now.
Oh, answer 3.
maybe some technical terms that you have seen people throw around. Remember, the best thing is being able to use this in person. So fingers crossed, next session, next month, we'll be doing a little bit more practical celestial navigation. Fingers crossed. And with that, I conclude.